So yesterday, before the fire drill, we were talking about in statistics. It's going to be our responsibility to read the statistic. So when we talk about a statistic, and we talked about this yesterday a little bit, you're inundated with them. They're all over the place. Okay, you see them in commercials, you see them in the news, you see them on websites all the time. They give you information that is trying to persuade you into a particular belief or train of thought. One of the largest places we use statistics is through medical research, okay? And with medical research, it's not so much that they're trying to persuade you, okay, but they're trying to determine the efficacy of a drug. Does that make sense? Or a treatment, okay? And to see how useful that drug is and whether that drug actually has an impact on the condition that it's treating, okay? And we'll talk about that kind of stuff. You guys have probably heard with the vaccine kind of stuff that's going on, and then doing treatments. If you watch it in the news, they talk about like double-blind tests and stuff like that. Have you ever heard those phrases? Or double-blind studies? Okay, we'll talk about those things, but those are statistic terms, if you've heard those, that are going to play a big role in the course. Okay, but when we're talking about statistics and you see them, especially when they're in commercials and stuff like that, or polls on the news, it's important for us to be able to interpret them, to do a little digging, a little bit of research to see, okay, who developed the poll? Okay, what was the survey? How did they develop the survey? Was it biased? What was the group that they sampled? What population were they trying to get an understanding for? And you look at all those things and start to decide, okay, was there really enough people to maybe convince me in this survey that I should believe the statistic that's being provided? Okay, and I think we talked yesterday about like politics. Okay, so if Fox News is going to survey a bunch of Republican registered voters about who they predict to be the president, it's probably going to be swayed towards the Republican candidate, right? Does that make sense? Okay, because there's bias there on who they poll. Okay, what you're going to start eventually seeing here as we get closer and closer to the election is more polls are going to be like structured or targeting independent voters, okay? Because obviously those are the people kind of in the middle that they're not going to associate and say they're Democrats. They're not going to say they're Republicans. Sometimes they'll vote Republican. Sometimes they'll vote Democrat. Sometimes they'll vote the independent candidate, okay? But those are the ones that are probably going to sway the election one way or the other. Does that make sense? Okay? So you'll probably see more and more of those types of polls coming out as we get closer and closer to the election, so they can kind of get a better prediction for those. Okay, it's interesting that whenever there is a poll conducted about some type of future event, to when that future event does occur, so we do have the election, we have a winner, to then go back and say, okay, how accurate were those polls that were being taken? Did they shed light on what happened, or did they not? Okay, it's just kind of interesting to do those types of things. So we talked about what a statistic was yesterday. Early on, we're going to talk mainly about descriptive statistics, okay? And that is exactly what it sounds like. They describe something, okay? Now, they might be a visual, okay? So I've got this graph down here of people that have are first-year college students and the amount of hours that they sleep in a day, okay? That's a descriptive statistic. We can visually see the relationship and the distribution of those data points, okay? If I were to give you like a pie graph or a Pareto chart or a histogram or a timeline or something like that, those are descriptive statistics as well. Even if I tell you the average of something or the median income of just your normal U.S. household, okay? I give you that number, that is a descriptive statistic over U.S. households. Does that make sense? Okay. There's another type of statistic we'll identify here in a little bit called inferential statistics, which deals with probability. Okay. But if we look at this exercise here, all it says is, we've got these 14 people that we've got data from and how many hours they spend sleeping a night, and we just plot their data points. Okay. And basically the questions down here at the bottom, we'll run through. I won't read these verbatim. Okay. But it basically asks us, what can we interpret from that data? What is the clustering of that data? What is the trend that we're seeing with this data? Any suggestions, any ideas? Where are most of our data points located? Between 6 and 7, right? So we're going to argue that, first-year college students out of this sample are clustering between 6 and 7 hours of sleep a night. Okay. Some outliers, maybe 9 hours is an outlier, right? Okay. And we'll go through some statistical operations that will validate whether it's far enough away from everything else to be an outlier. But 9 hours might be an outlier. And then we can start thinking, okay, well, why? Maybe we look at that individual person and say, well, they've got a scholarship, they don't have to work a job, and then they don't have a bunch of classes to study for, so they have more time to sleep, right? So if I look at the 6 to 7, okay, those might be your first-year college people. They might have a heavy load, and they might have to have a part-time job, so they are limited on the hours of sleep that they can have, right? Does that kind of make sense? So not only do we look at the data, but then we start thinking about, okay, now what is maybe the reason for that data? Interpret that data, okay? What if we took the same class, this class here, and did the same thing and clustered our hours of sleep? Would they be similar to this, or would they be drastically different? What do you think? How many hours you guys sleep a night? Did you say 11? Huh. 8? Okay. About 8 hours. Okay, it's healthy, right? Okay. Anybody sleep like 3 hours? 4, 5? Okay. So you guys are like college students, right? You're almost a college student yourself. Okay. Some of you play athletics, right? Okay, sports or whatever. That might minimize the amount of time that you can sleep. You've got studies to do. So maybe averaging, maybe our cluster is around 7 to 8 or 9. So maybe this cluster here is moved over a little bit if we were to collect our own data, right? Okay. So what we're trying to see there or visualize there is that depending on the group that you study, their clustering is going to be different, right? What if we did patients in the nursing home or residents in the nursing home? Where do you think the data would rely there? 9? More? 10? I mean, this is my plan. When I retire, I'm going to sleep. Okay, that's what I like to do. Okay, so if you go to a nursing home and experience time in a nursing home, there's a lot of people sleeping in nursing homes. Okay, so maybe they are further along 8, 9, 10 hours a day. Okay, at the same time, think about that generation of people. Anybody got parents, grandparents that wake up at like 5 in the morning and then go to bed at midnight? My grandparents did that all the time. 5 in the morning. They were farmers, so they had to get up. They got up early and then went to bed late, and they were just programmed their bodies 5 to 5 in the morning, go to bed at midnight. Okay, so when my grandma and grandpa went to nursing homes, they did the same thing. It was just what they were used to. Okay, so you might have clusterings at 5, but you might also, because of the health conditions of some people in nursing homes, you might have clusterings at 10, 11 hours. Does that make sense? So the distributions are going to be different. This one kind of looks, if you guys know what a bell curve looks like, this one kind of looks like a bell curve. Okay, and that's probably what you can probably expect, but they don't have to. In a nursing home, it might be, you might have a steep, I don't want to say steep, a rise down here, and then a valley, and then another maximum over here. Does that kind of make sense? Okay. But those are things that we'd have to we'd actually collect the data, investigate, and see, do those assumptions that we made or that we think could happen, are they really happening in that nursing home or whatever environment that you choose people from. Okay, so doing things like that is a study in statistics. Okay, that's just trying to analyze data, trying to interpret a situation. One of the things that we like to do is organize the information. Not only just collect the data, because data as what we call raw data. So if I just collect your ages and I just put them in an Excel sheet and don't do anything with them, don't organize them, don't sort them or anything like that, it's just considered raw data, just numerical values. Raw data a lot of times isn't all that useful. Okay, it doesn't prove any points. Okay, we want to take that raw data and organize it, put it into charts, put it into, we got pie charts up there, we got histograms, we got those types of things, because now it's easier for us to read, right? It's easier to make judgments. It's easier for me if I'm publishing that and I want to persuade somebody, maybe it's easier to do that. Okay, if I'm let's say that stuff over there on the right, instead of going freshman, let's say that's like money spent on freshmen, money spent on sophomores, money spent on juniors, money spent on seniors. As I'm a high school principal and I'm trying to go to the Board of Education and prove a point that we're spending way too much money on a certain group of students that is unparalleled to the other students. So the other students are at a disadvantage, right? Would me taking that chart to the board and showing them that maybe convince them visually that he's right. We are paying a lot more or giving a lot more money or resources to the freshman class versus the senior class. Does that kind of make sense? Okay, so I can use that stuff instead of just giving them a number, because not everybody is great at comparing numbers, but if I give them the visual of a pie chart, something like that, that can persuade people a little bit better, okay, a little bit easier. We said two ways of summarizing data are by graphing and by using numbers. That is what descriptive statistics are, by using graphs and numbers that represent data. Okay. We won't get too far with this concept here. We'll talk about it, and that will kind of wrap things up. This is all the further we got in first period. But an inferential statistics. So this is early on in the course. We're going to talk about descriptive statistics. So I'll show you like the rules for creating a histogram, the rules for creating a Pareto chart, the rules for creating frequency distribution, okay, and the steps for doing that kind of stuff and breaking up class boundaries and stuff like that for data. And that's the first couple chapters. We'll do a chapter of probability where we're talking about rolling dice and picking cards and that kind of stuff. Because then eventually we will morph into inferential statistics, which incorporates probability. So we need to have a good understanding of probability, okay? But inferential statistics says after learning probability and probability distributions, you will use formal methods to draw conclusions from good data. So this is what is used in like medical research. It's used in like educational research. So when I was getting my master's degree in education, I had to write a research paper, okay? And I had to actually conduct legitimate research, and my paper was like 60 pages long. And you have to use statistics in that research paper. So you guys have done research papers in high school, right? But there was never any math involved in that, right? When you get to the college level and they say a research paper, that means you're conducting surveys, you're collecting data, making hypotheses, and then doing the statistical test to see if those hypotheses are true or false. Okay. So what I did is it was like the first year that we all had computers, and I took the scores of previous OGTs at that time. It was the Ohio graduation test. You guys ever heard those before? It took the place of the end of course exams. Took those scores, and then I took the scores of the year that we started with computers. I wish I had more data, more years of computers. We had 1 year of computers, and I tried to see, did the computers impact the OGT scores? Does that make sense? Okay. And my hypothesis was initially that they should, that the computers, the technology would increase those scores. The data showed that there was no correlation. Okay, data showed with computers or without computers, there was no change in that variable. Does that make sense? Or that variable didn't have an impact on those scores. But that was inferential statistics. Okay. If I'm going to try to find the effectiveness of a drug, okay, we're going to use inferential statistics to do that. Okay. So the formal methods are called inferential statistics. Statistics inferences use probability to determine how confident we can be about our conclusions and whether they are correct. Okay. So you might have you ever heard of what a confidence test is? Or you might read something that says, I'm 95% confident that this is the situation, this is true. Those are called confidence tests, and they have to deal with probability. And the less confident I am, obviously the more unreliable that data is. Does that make sense? Okay. Or the unreliable that truth is that I'm trying to show. But that's inferential statistics, and that's a big part of the class. Early on, when we start talking about like finding averages and means and that kind of stuff, that's important, but the class is really geared, in my opinion, towards inferential statistics and how I use distribution tables and normal curves and probably those charts I showed you a couple days ago. Using those charts is inferential statistics. Okay. So cool. All right. Early on, guys, just a bunch of vocabulary. You know, I'd hate to get into, you know, the nuts and bolts of stats and using vocabulary, using terminology that you have no understanding of, that you've never heard before, and lose 2/3 of you because, well, you don't know what I'm talking about. Okay. So you're going to see the first chapter, a lot of vocab. Now, things like inferential statistics, because it's going to be something we talk about later on again, when we get there, I'll redescribe the idea, redescribe the vocabulary, that kind of stuff. But a lot of the stuff I want to make sure, key terms, we have a good foundation before we move on.